In this video, we're going to talk about the parallel circuit rules. And just like the series rules, there are 4 of them. We will cover each rule in its own video in future lessons. For now, we're just going to define them and give a quick explanation of what they mean. Rule number 1. Source voltage is applied to all legs in the circuit. And all that means is that if you look at the parallel picture in the top left here, it means that the battery is supplying full voltage to each leg in the circuit. And that means that each resistor is connected to both the positive side of the battery and the negative side of the battery. Whereas if you compare that to the series circuit on the right, the voltage gets shared by the 2 resistors because of the way they're arranged. If I was using 2 bulbs as my resistors in the parallel circuit, both bulbs would be bright because they're each getting 12 volts. They're each connected to the positive side and the negative side of the battery, and let's assume that this is a 12-volt battery in each picture. So both bulbs would be bright because they're both getting 12 volts. And that's the reason we use parallel circuits, is because it does allow each load to get the full battery voltage. Whereas in the series circuit, if there were 2 bulbs there instead of the 2 resistors, they would be sharing the voltage. And as you learned in series circuits, if they're the same type of bulb or the same resistance value, they would share it equally. And if they were different values, the one with the higher resistance would get more of the voltage. Rule number 2. The total current is the sum of the current flowing in each leg. And all that means is, if we have only one path like in series, the total current is equal to the current anywhere in the circuit. But in a parallel circuit, since it branches off into multiple paths, and in the case in the top left here, it's just 2 paths, what rule number 2 is saying is the total current is equal to the sum of the current that's going through path number 1 plus the current that's going through path number 2. And we'll illustrate this better when we explore this rule in its own video. Rule number 3, the current flowing through each leg depends on the amount of resistance in each leg. And what this means is that if I have one leg or one path in a parallel circuit that has a high resistance, that path will have a small amount of current flow going through it. Whereas if the other path has a lower resistance, that other path will have a higher current flowing through it. But keep in mind that the total current is always going to be the sum of the 2 paths, regardless of how much each path is contributing to the total. Rule number 4. The total resistance is always lower than the resistance of the lowest leg. Now this one's a little trickier to understand. When we learned about series circuits, the way to find the total resistance was just to add up the 2 resistor values. And if you added more resistors, your resistance went up. What this rule is saying is that if you keep adding more paths, the total resistance of the whole circuit goes down, and it has to be lower than the value of the lowest leg. Now let's think of this as if I had 20 students in a classroom, and I had 2 paths. Let's say there was a door in the front of the room and a door in the side of the room, and it was time to leave. Some of the people would go through one door, and some of the people would go through the other door. And what if there was a way to now add a 3rd door? Even if it was a small door, wouldn't some of the people in the room go through that other door, and now it has just become easier to get out of the classroom? And you can even think of it another way. What if I had a bucket of water and I put 2 holes in the bucket? Having 2 holes in the bucket, it has to be easier for the water to get out of the bucket than if there was only one, regardless of how big the second hole is. And if I added a 3rd hole in the bucket, the flow out of the bucket of the water would face less resistance because now there's more paths. And we will spend some time with the parallel resistance formulas so that we can understand how to calculate what that resistance value is, because it's not as simple as just adding them together. There's actually a couple of formulas, and we'll go through them in detail in a later lesson. So for now, these are the 4 essential rules for parallel circuits, and in the next video we will break it down and give each rule the attention they deserve and try and illustrate it in a way that we can understand it better.